Welcome to MiniWeb Tool. Today, we're going to demystify the hidden math that powers pretty much everything you use. Your computer, your phone, all of it. It's called the binary logarithm. Now, that might sound super complex, but trust me, it's the secret sauce that lets computers handle massive amounts of data in the blink of an eye. Stick around and you'll see just how simple and, honestly, how cool it really is. So here's what we're going to cover. We'll break down what a binary logarithm is using a really simple method you won't forget. We're going to dive into why it's so critical for all technology, and I'll show you an incredibly easy way to calculate it for any number you can think of. By the end of this, you'll get it, I promise. Okay, so to get started, let's not begin with a dry, boring formula. Instead, let's kick things off with a riddle. This little puzzle is the perfect way to show you the raw power of what we're about to learn. Imagine this. Your friend is thinking of a number, any whole number between 1 and 1,000,000. Your job is to guess it. The catch? You can only ask yes or no questions. So how many questions do you think you'd need to guarantee you find that number? 100? Maybe 1,000? It seems like it would take forever, right? The answer, and this is what's so amazing, is just 20 questions. That's not an estimate. It's a guaranteed maximum. 20 questions to pinpoint any single number out of 1,000,000 possibilities. This isn't magic, it's just the binary logarithm showing off its incredible efficiency. Now, if hearing the term binary logarithm just made you kind of tense up a little, you are definitely not alone. There's a really good reason why this topic often feels so confusing, and it has absolutely nothing to do with you being bad at math. The problem is, this is what we're usually shown in school, some abstract formula totally disconnected from any real-world meaning. We're taught the how before we ever understand the why, and our brains just kind of check out. It feels totally pointless because nobody gave us a reason to care in the first place. So, what happens when you try to look it up yourself? Well, you usually get hit with a wall of super dense technical jargon, academic papers, confusing articles. It's all just so unhelpful. You're just looking for a straight answer, and it's incredibly frustrating. And the final headache is just trying to calculate the thing. You pull out your calculator, you hit the log button for 16, and you get this weird decimal, 1.204. What is that? Well, that's because standard calculators use what's called base 10. Computers, and what we need, use base 2. It's just a pain. So let's just throw all of that frustration out the window. Forget the formulas. We're going to reframe this whole idea with a couple of simple, intuitive questions that anyone can understand. Let's build a real gut feeling for what this is. At its absolute core, this is all a binary logarithm is asking. It's a simple question. How many 2's do I need to multiply together to get my number? That's it. So for the number 8, you'd think, okay, 2 times 2 is 4, times 2 again is 8. That took 3 2's. So the log base 2 of 8 is 3. Simple as that. Now, here's another way to think about it that I find even easier. I call it the halving method. Just ask yourself, how many times can I cut my number in half before I get all the way down to 1? Let's try it with 16. Cut it in half, you get 8. Again, you get 4. Again, 2. One last time, and you get 1. See that? It took exactly 4 cuts. So the log base 2 of 16 is 4. The key thing to realize is that these are just two sides of the same coin. Whether you ask, how many 2's do I multiply to get to 8, or how many times do I cut 8 in half to get to 1, the answer is the same, 3. It's a really simple and powerful idea. So at this point you might be thinking, okay, I get it, but why the number 2? Why are we so obsessed with 2? And the answer is, well, it's fundamental to every single piece of technology you own. It's because computers think in binary. Their entire universe is built on a simple two-state system. It's either on or off, true or false, 0 or 1. Each one of these little switches is called a bit, and it's the smallest possible piece of information there is. Now here's where it gets really interesting. Look at how fast the possibilities grow. With 1 bit, you have 2 options. Add a second bit, now you have 4 combinations. With 3 bits, you jump to 8. You see the pattern, right? The number of things you can represent doubles with every single bit you add. It grows exponentially. The binary logarithm just flips that question around. It lets us ask, okay, if I need to store a certain number of things, how many bits do I actually need? So to store 64 different possibilities, say 64 different items in a game, you need the log base 2 of 64. And the answer is 6. You need exactly 6 bits. And this brings us full circle, right back to our original riddle. Guessing a number between 1 and a million is really a data problem. Every single yes or no question you ask is like a bit. It cuts the remaining possibilities in half. So the number of questions we need is simply the log base 2 of 1 million. All right, so the halving trick is fantastic for clean numbers like 8, 16, or 64, what we call perfect powers of 2. But what about all the other numbers? What happens when our cool mental math trick doesn't work? For example, what's the log base 2 of 10? Our intuition still helps here. We know the answer for 8 is 3, and the answer for 16 is 4. So for 10, the answer has to be somewhere between 3 and 4. But what is it exactly? For that, we need a better tool. And this is where that final frustrating problem gets solved. Instead of fumbling with a complicated calculator, you can use a simple, free tool like the mini web tool log base 2 calculator. You literally just type your number into the box. So let's try it with 10. We type it in and we instantly get our answer, 3.3219, exactly like we predicted. It's a number right between 3 and 4. In computer terms, this tells us that to store 10 different things, you'd need at least 4 bits of information. And now, for the grand finale, let's go back to our riddle. What is the log base 2 of 1 million? We plug it into the calculator, and we get 19.93. Now, since we can't ask 0.93 of a question, we have to round up. And there it is. That's the mathematical proof for why we need 20 questions to guarantee we find the number. Okay, let's do a quick recap of the big ideas here. First, the binary logarithm isn't scary. It's just asking, how many times can I cut this thing in half? Second, it's the basic language of computers, telling us how many bits we need to store information. And finally, it's a measure of pure efficiency, showing us the absolute fastest way to find something in a huge amount of data. So the next time you hear about bits, data compression, or search algorithms, you'll know the simple, powerful math that's running the whole show. You actually understand the language of information itself now. If you want to try it out, just search for mini web tool log base 2 calculator to find the free tool and get your own results in seconds. To continue learning with more clear, straightforward explainers like this one, be sure to subscribe to Mini Web Tool.